Welcome to the newsroom. Let's just dive right into this explainer and absolutely conquer that deadline pressure of the Cambridge exams. Think of your upcoming computer science exam as a high-stakes breaking news deadline. You're sitting there, the clock is ticking loudly, the pressure is immense, and you literally have to break down the story, which is your exam question, and deliver the headline, which is your perfectly structured, high-scoring answer. Today, we are focusing on a topic that is notoriously misunderstood across the entire syllabus. I'm talking about addressing modes and specifically indexed addressing. Now, whether you were studying the syllabus codes 0417, 0478, 0983, 0984, 2210, or that advanced AS and A-level 9618, the core challenge is exactly the same. Honestly, year after year, we see students lose incredibly easy marks when they're asked to interpret complex binary representations and deal with index registers. It's like a giant puzzle where everyone has the pieces, but they just panic and force them together backward. But by the time we finish this explainer today, you definitely won't be one of those students. We are going to reverse engineer the examiner's playbook together and give you the exact, foolproof blueprint to secure maximum marks. Here is our cognitive cheat sheet for today's session. We're moving systematically through 5 acts. Act 1 is the challenge. Act 2 is the strategy reveal. Act 3 is the transformation. Act 4 is an interactive workshop. And finally, Act 5 is the blueprint system. Let's get right to it. Act 1, the challenge. Let's really look closely at why smart students are consistently losing these easy marks. Okay, I want you to picture this scenario. It's exam day. You turn the page, and boom, there it is, a terrifying, complex question on indexed addressing. You're given a base address in binary, you have an index register value in hexadecimal, and there's a highly specific memory constraint. Now, let's look at 2 hypothetical students, Alex and Sam. Both of them studied incredibly hard. Both of them totally know what an index register is. But when faced with the deadline pressure of this specific Cambridge-style question, they both crumble. And they crumble for completely different reasons. This brilliantly illustrates the 2 biggest traps you absolutely have to avoid. Alex, on the one hand, sees the words indexed addressing and goes into full red alert panic dump mode. Alex just writes down literally everything memorized from the textbook. Things like indexed addressing is when the address to be used is calculated by adding the value in the index register to the base address. Now look, that is a perfectly accurate, raw computer science fact. Hit the nail on the head, right? But Alex gets 0 marks for application. Why? Because there was absolutely no analysis of the specific binary values given in the scenario. Now look at Sam. Sam's problem is different. Sam rushes. Sam actually calculates the correct address, but completely ignores the command word at the start of the prompt, which was evaluate the suitability of indexed addressing for this array. Sam doesn't evaluate anything. Sam just describes what happened. So you have 2 dedicated students, 2 different approaches, and both are losing massive marks simply because they failed to break down the specific story the examiner was asking for. So, what does this all mean? Why do students find interpreting complex binary representations so intensely difficult under pressure? It's a critical question, and to answer it, we have to look under the hood at the distinct cognitive domains that examiners are actually testing you on: knowledge, application, and analysis. You see, the theoretical architecture of indexed addressing isn't just about rote learning definitions, not at all. It rests on precise causal relationships and deep integration with other syllabus areas. When you look at a complex binary representation, your brain has to simultaneously perform 3 totally different tasks. First, knowledge retrieval, asking, what even is a base address? Second, application, figuring out, how do I add this specific binary index to this address? And third, analysis, asking, what actually happens if this resulting addition exceeds the memory bounds? When students panic, their brains literally shut down the higher functions, and they default back to just that base knowledge domain. They write down facts. But the Cambridge assessment objectives strictly require you to climb up that cognitive ladder. The principal examiner reports consistently highlight that candidates who reference cross-topic connections, like linking indexed addressing to arrays or iteration, achieve significantly higher marks. Act 2, the strategy reveal. It's time to introduce the method mark strategy and change the way you answer these prompts forever. Now, what's really interesting about this next phase is how the absolute top candidates reverse engineer the examiner's playbook. If you know for a fact that examiners are explicitly looking for application and analysis and not just raw knowledge dumps, you can actually structure your answer to force the examiner to give you those marks. We need to shift away from chaotic, off-the-cuff writing and introduce a highly systematic, algorithmic way of structuring an exam answer. So the absolutely crucial point here is applying the Peel framework to ensure your index-addressing answers integrate flawlessly with broader architectural concepts. Let's break this structure down because it's a real game changer. First up, the P stands for point. You immediately identify the algorithmic step required by the command word. Second is E for evidence. You extract relevant data directly from the question prompt, like stating the actual base address provided in the scenario. The next E is for explanation. This is where you analyze cross-topic connections, like clearly explaining how incrementing the index register optimizes execution speed. And finally, L for link. You connect back to the theoretical architecture or the specific scenario given in the prompt. By using Peel, you naturally hit every single cognitive domain the examiner is grading on. And honestly, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's put this to the test. Let's take a 30-second mental challenge to spot the correct Peel structure. Imagine I put 2 paragraphs in front of you, and you need to identify which one successfully uses that point, evidence, explanation, link framework we just discussed. Let's say paragraph A talks very broadly about memory management in a computer system, but uses absolutely no numbers from the source text at all. Meanwhile, paragraph B starts by outlining the mechanism, then explicitly inserts the hexadecimal base address from the prompt, explains the memory offset in detail, and finally links it all back to loop efficiency for the system. If you chose paragraph B, you are absolutely right. Paragraph B is engineered perfectly to extract maximum method marks from the examiner. It leaves nothing to chance. Act 3. The transformation. Let's take all of this theory and look at how to actually secure those method marks in practice. This 5-step procedural framework right here is your ultimate blueprint. Remember, examiners award what we call method marks for this exact step-by-step algorithmic decomposition. It's not just about the final answer, it's about how you got there. Let's mentally walk our 2 struggling students, Alex and Sam, through this exact transformation. Step 1, deconstruct the question. You physically underline the command words on the paper. Are you explaining, evaluating, or calculating? Know the difference. Step 2, extract relevant data. Pull out the base address, the index register value, and absolutely any memory limits hidden in the text. Step 3, select the analytical framework. For a question involving an array, your framework is always going to be base address plus index offset. Step 4, execute with clear notation. Write out your binary addition so clearly that the examiner can effortlessly see you're working. Don't make them guess. And step 5, present with correct terminology. The principal examiner reports literally scream about this every single year. Candidates consistently confuse key terminology. Do not just say it moves the memory, that's way too casual. Say it calculates the absolute address by adding the index register offset to the base address. When you systematically apply these 5 steps, those chaotic, panic-induced paragraphs transform into incredibly precise, high-scoring technical responses. I really want you to internalize this critical insight, which comes straight from the source. Candidates referencing cross-topic connections achieve significantly higher marks. It is not just about knowing the binary rules in a complete vacuum. It's about connecting those calculations to the broader architectural concepts across the entire syllabus, things like loops, memory management, and array processing. That kind of integration is the exact signal an examiner needs to see that you truly understand the whole shebang. Now, stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Moving right along to Act 4, it's time for our interactive workshop. Let's practice some real-time, high-pressure problem solving. Okay, it is time to apply our deconstruct, solve, evaluate method under real deadline pressure. Problem solving in indexed addressing requires you to identify given information, break it into logical steps, solve it systematically, and, this is critical, check for reasonableness. For challenge 1, I want you to mentally scan this algorithm quality matrix to evaluate the performance of an indexed addressing solution. Imagine you have a 60-second visual countdown ticking in your mind. Higher order assessment objectives demand that you evaluate alternatives and compare different approaches. So look at the time complexity row. Using an index register to traverse an array has a massive, measurable positive impact on execution speed simply because you avoid rewriting instructions. Pretty cool, right? Now look at space complexity. It requires minimal extra memory allocation, making it highly efficient. But look closely at the 3rd row, edge cases. This is where the system stability risks lie, and this is exactly where the Cambridge examiners lay their traps to catch rushed students. For challenge 2, we are going to find the flaw in a sample paragraph by noticing that the student completely forgot to check for this crucial condition. So imagine a student writes this on their exam. The algorithm will increment the index register from 0 to 255, adding it to the base address to read every element of the array perfectly. Okay, sounds confident. But what is the fatal flaw there? The flaw is they never actually checked the boundary condition. Think about it. What if the array only has 100 elements allocated in memory? If the index register blindly increments all the way to 255, it will absolutely cause an array overflow. It's going to start reading data from unauthorized memory spaces, ultimately causing severe system instability or a total crash. Examiners report year after year after year that students forget to check boundary conditions and edge cases in indexed addressing. If you do not explicitly mention handling these limits in your evaluation answers, you are literally leaving guaranteed marks sitting on the table. All right, let's turn up the heat. For challenge 3, you have exactly 30 seconds to write a response in your head that is highly specific to the context given in the question. The prompt is, explain one advantage of using indexed addressing for manipulating a 50-element array of temperature readings. Ready? Go. Remember your Peel framework, your point, the advantage is highly efficient sequential access, your evidence, the specifically mentioned 50-element temperature array, your explanation, by storing the base address of the very first temperature reading and simply incrementing the index register from 0 to 49, that same base instruction can be reused over and over. And finally, your link. This fundamentally reduces the overall program size and speeds up the processing of the temperature data. Time is up. Did you notice how I practically forced the context into that answer? I didn't just casually say the array, I explicitly said the 50-element temperature array. Your answers absolutely must be tied to the specific context given in the question to get full marks. And that brings us to Act 5, the blueprint system. This is our final deconstruct and evaluate methodology. Let's consolidate absolutely everything we've talked about into the ultimate computer science success blueprint. We've completely deconstructed the cognitive demands of the 9618 syllabus. We've seen exactly how to reverse engineer the examiner's playbook using that Peel framework. We've deeply analyzed time complexity, space complexity, and the critical hidden danger of edge cases. Now, we wrap all of this up into a straightforward, undeniable system that you can carry with you right into the exam hall. When that deadline pressure hits, you simply won't panic. Following these 3 rules guarantees you secure maximum method marks while entirely avoiding the confusion of key terminology. Rule 1, command word decoding. Always know what you're being asked to do. Rule 2, Peel framework application to ensure you hit all those necessary cognitive domains. And Rule 3, the time management matrix, strategically allocating your time based on the actual marks available and making absolute sure you look for those dangerous edge cases. Now, these are insider secrets straight from the principal examiner reports. Ignoring these 3 specific things will definitely cost you easy marks. Let's hammer this home one last time, guys. Warning 1. Students constantly forget to check for overflow and edge cases in addressing modes. Don't be that student. Warning 2. Students forget to check boundary conditions. Remember, if your index register goes past the allocated memory, your whole system crashes. Point that out to the examiner. Warning 3. Answers are not specific to the context given in the question. If the question is about a robotic arm's memory, you need to talk about the robotic arm, not just some abstract system. Always define your terms before using them in your extended responses and perfectly ground them in the scenario they've given you. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. I mean, really think about what a 2-grade boundary jump actually means for your future. It is literally the difference between getting a C and securing an A. It is the difference between struggling to understand basic binary representations and confidently breaking down the theoretical architecture of an entire CPU system. The strategies we discussed today, algorithmic step-by-step decomposition, integrating those vital cross-topic connections, and religiously checking for edge cases, these are the absolute hallmarks of a top-tier candidate. But just knowing the strategy isn't enough. You have to put in the reps. Don't let another exam pass you by relying on simple rote memorization. By applying these specific frameworks, you can stop carrying the incredibly heavy burden of disconnected facts and instead unlock a real treasure chest of algorithmic thinking. You effectively build a personal database of cognitive cheat sheets. We do all the heavy lifting of reading through years of dense Cambridge reports to pull out exactly what you need to know, so you can spend your valuable time actually practicing and perfecting your Peel paragraphs. So here's your final reminder. Subscribe to our YouTube channel, AC Exams, at acetheexams_IGCE, to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCE and click that bell. Don't let another exam pass you by. Whether it's indexed addressing, time complexity, or algorithmic decomposition, you now have the exact tools you need to break down the story and deliver the headline. But here is the ultimate question to ask yourself before you walk into that exam hall. Are you just memorizing the code, or are you actually testing your algorithms thoroughly? Keep practicing, keep applying the framework, and don't forget to connect with us. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams, your Cambridge success starts here.